Hi, this is Alex from devstories.eu. Prompt Flow, the Complete Guide, Episode 9 of 14. Sometimes staring at a wall of code is not enough to understand a complex application. When prompts, scripts, and API calls interact in dozens of ways, you need to physically see the data moving between them to spot the bottlenecks. DAG flows are the answer for teams that want explicit architectural clarity. DAG stands for Directed Acyclic Graph. In prompt flow, a DAG flow is a method of building AI applications by linking different tools together as nodes. Instead of writing a single large script, you define your application's structure in a file named flow.dag.yaml. This file acts as the master blueprint. It declares the starting inputs, the individual steps, and the final outputs of your application. Every step in a DAG flow is called a node. A node represents a specific tool performing a single task. You might have a node that runs a Python snippet, another node that formats a prompt, and a third node that calls a large language model. The YAML file describes how these nodes relate to one another through input and output dependencies. This dependency mapping is what makes the flow work. You do not manually tell the system what order to execute the steps in. Instead, you specify that node B requires the output of node A. Because node B cannot start until node A finishes, an execution order is naturally formed. If you add node C that only depends on the initial user input, prompt flow will recognize that it does not need to wait for node A or B. It will run node C in parallel automatically. The engine reads the YAML file, resolves the graph, and handles the orchestration. Writing and maintaining this YAML file by hand can become difficult as your application grows. That is why most developers use the Prompt Flow VS Code extension. This extension reads your flow.dag.yaml and renders a visual drag-and-drop user interface. You can view your application as a literal map of connected blocks. Consider a concrete scenario. You're building an application to read financial reports and write short executive summaries. In the visual editor, you create a Python tool node and name it Extract Text. Next to it, you add an LLM tool node named Summarize. Rather than writing code to manage the state between these two operations, you use the interface. You click the output port on the Extract Text node and drag a line to the input port on the Summarize node. You have just visually wired the data path. The extension instantly updates the underlying YAML file to record that connection. You get the speed and clarity of a visual low-code builder, but you still generate a plain text configuration file that you can track in version control. This visual approach forces architectural discipline. The graph is acyclic, which means data can only flow forward. There are no infinite loops. Data comes in, passes through your sequence of tools, and exits. This strict directional flow makes debugging straightforward. If a final summary looks wrong, you can open the visual graph, click on the connection between the extraction and summarization nodes, and inspect the exact string of text that was passed across that wire. You know exactly where the data came from and where it went. The real advantage of a DAG flow is that your system architecture diagram and your executable application are the exact same thing. That's all for this one. Thanks for listening and keep building.